we are going to talk about R's and R minus 1's complement. Which is as usual, the R could be any base, right? It could be base, R could be here. Actually add inside the parentheses, R here could be for our actually course at least, could be 2, 8, 16, and 10. But in general, it could be any number, okay? So for example, whenever you have a number in base 2, what is the R's and R minus 1's complement? You will have 2 complement and also 2 minus 1 1's complement, okay? Whenever you are in base 8, you have 8's complement and 7 complements. Whenever you are in base 16, you have 16 complement and 15 complement. Whenever you are in base 10, you have 10 complement and 9's complement. So let's see what they means and what is the application of them. So we start with just simple definition for that. Then we will learn actually a more simple way to get the R and R minus 1 complement of any numbers. So here you see the definition, which is in the book. I just write it down here. So give a number n in base R, actually having n digits in the left side of the point, and m digits in the right side. In the right side of the point, okay. So if that's the case, so these are the definition of the R and R minus 1 complement. So the R's complement, meant of n, which is your number, equal to R power n minus n. And in the other side, the R minus 1's complement definition is this. Complement of n equal to R power n minus n minus R negative m, okay? So that's actually definition of that. So I could give you an example. So suppose you have these numbers. So if suppose you have actually this number that you see 1 0 1 1 0, okay? So I actually, this is n, you read big N, okay, capital. So the first question is based off these definition that you see first. You need to know what is the R here. So the R, back to the definition, you have number n, which is this number in the base R. So that means this number is in base 2, so the R here is 2, okay? So it actually has n digits in the left side of the point. So this is your point. So this is the left side. How many number we have? We have 2. So that means n is 2. And m digits in the right side. This is your point. On the right side, you have again 2. So that means your m is 2. Okay, then you are done. You could actually get R's complement. You tell me R's complement is here what? 2's complement, because R here for this is actually base 2. So 2 complement, we could have 1's complement, which is R minus 1, which is 2 minus 1, right? So the 2's complement of the n, 2's complement of this number is equal to, you see the definition, r, which is 2 power n. What is the n? N is 2, okay, minus actually n, right? N is the whole numbers that you have, which is 1, 0.10. Okay, so definitely you couldn't do this subtraction because one side of this is actually decimal, the other side is binary. Technically, you should convert this to the binary or convert this to the decimal, then you are able to subtract, right? Whenever you subtract, the both sides should be actually in the same base. But we have actually the more simple way. We never actually go and calculate this. So write the definition for the first complement. Again, Rn, which is 2 power n is 2 minus n is 1010 minus r negative m. So again, r is 2 and negative m is negative 2. And this n was 2. I forgot to write this 2. Okay, Rn is 2 power 2 negative. So this is definition of them. Okay, so whatever you got here will be the 2 complement and first complement of these numbers. But as I already mentioned, we never go and calculate whatever you have here, and we never use the definition of them. So we actually have 2 shortcuts for finding the r's complement and also for finding the r minus 1's complement. We usually use these 2 shortcuts, which is the easy way to get r and r minus 1's complement. So let's see how they works and how you could use that shortcut.